Ever get this weird feeling like the buildings we see every day, or even like a butterfly's wings, have something in common?
It's funny you should say that.
Yeah,
Yeah, because it's geometry that connects those things. It's everywhere once you start noticing.
it's true. And that's what we're diving into today. All those points, lines, shapes, they're like the secret code behind, well, almost everything.
It's true.
And our guidebook for this deep dive is 4 basic geometrical ideas.pdf. Don't let the simple title fool ya.
Oh, I agree. This document it's a treasure trove of really profound ideas.
Right.
For example, it shows how geometry went from this practical thing, like dividing up land in ancient times.
Oh, yeah, back then it wasn't about like fancy theorems, right?
No, not at all. They needed a way to measure accurately, make sure everyone got their fair share.
Makes sense.
And from that need, boom, the fundamental principles of geometry were born.
Wow.
And we still see those principles today. I mean, look at surveying, mapping, even how our cities are planned.
It's mind-blowing when you think about it, how those early attempts to understand shapes in space led to such complex things. And speaking of shapes, I gotta say, I love how our source uses examples we can all relate to, like tiffin boxes or those bangles people wear.
Oh, absolutely.
It makes those kind of scary-sounding terms like line segment or curve way less intimidating.
It's all about making those connections to the everyday. Even something as simple as looking around your living room right now, can you spot any parallel lines?
Ooh, good point. And speaking of those basic building blocks, points, and lines, did you know that just 2 points, 2 tiny little dots, can define a line that theoretically goes on forever?
It's a pretty amazing concept, isn't it? And it's one that's fascinated mathematicians and artists for, well, forever, really. Think about perspective drawing. Artists use what we call vanishing points, those points where parallel lines seem to meet to create the illusion of depth.
Whoa, so on a flat canvas, they're actually using geometry to trick our eyes into seeing 3D.
Exactly.
That's so cool.
It's like those vanishing points are guiding your eye, right?
Yeah.
Showing you a line that keeps going even when you can't see it anymore.
It's like, whoa, geometry is about what we don't see, too. Which, okay, speaking of seeing things in new ways, when our source talked about curves, it really made me think about how they shape how we experience things. Like, think about a river. All those bends and turns, right? All open curves.
Yeah.
But then compare that to being inside a room. You know, those walls are closed curves, and they totally define the space.
Totally. It's like open curves, they give you that feeling of movement, freedom, but closed curves, they're all about enclosure, making things feel safe and stable.
Yes. And those closed curves, the ones that make an actual enclosed space, those lead us to polygons, which our source gets into as well.
Right, right.
It defines them as closed figures made of straight lines, and it's super interesting that triangles, the simplest ones with the fewest sides, are also, like, the strongest shapes.
It's that inherent stability they have. You put force on a triangle, it distributes that force evenly. Super hard to break. But quadrilaterals, with their 4 sides, much easier to bend or collapse under pressure.
That's gotta be why we see triangles everywhere in construction,
Yeah.
right? Bridges, those huge electrical towers. It's all about that triangle strength.
Exactly. Understanding even just basic shapes like that leads to really practical, but also kind of elegant solutions in engineering, architecture.
It really shows how connected all these concepts are.
Absolutely. And that takes us to another super important shape, to circle.
Okay, so our source had this cool activity where you use sticks and rope to actually make a circle.
Oh, yeah.
It makes it so clear every single point on the edge of the circle is the same distance from the center.
That's the defining characteristic of a circle, that constant distance.
Yeah.
And it's what gives it that perfect symmetry.
And it's everywhere, from wheels to, like, the orbits of planets. It's crazy.
It really is.
It's even in our technology. Like, GPS uses that whole central point radius thing to figure out where we are.
And think about cell phone coverage. The signal's stronger or weaker, depending on how far you are from that central tower.
Yeah.
But going back to the sticks and rope for a sec,
Yeah.
it's also a real good way to visualize all the parts of a circle. The diameter, the chord, the arc.
Right. You're not just memorizing terms. You're, like, discovering them. You fold a circle in half. That crease, that's the diameter.
It really makes it click, you know.
Totally. And, you know, it's funny. We think of geometry as all, like, strict rules, but it also lets us be so creative.
Oh, absolutely. The best architects, they use geometry to make buildings that are useful but also beautiful. You know, they're playing with light, space,
Right.
all based on these geometric ideas.
It's like geometry gives them the tools, But what they build is up to them. Whether it's a bridge or even like a complicated mosaic, those shapes are everywhere.
And the thing is, we don't have a monopoly on it. Nature's got geometry figured out, too. Look at a nautilus shell, those honeycombs bees make, even a snowflake.
It's like there's this hidden pond, right? And once you start seeing it,
It's everywhere.
it makes you wonder what else is out there, just waiting for us to notice it.
That's what's so great about it. We've just scratched the surface, but hopefully this gets you thinking about geometry differently.
It definitely does. So to everyone listening, we challenge you, start looking for geometry everywhere you go. You might be surprised what you find. That spider web. Geometry. Grandma's quilt. Geometry again.
Those curves, the polygons hiding in plain sight. It's not just about formulas. It's like the language of everything around us.
Wow, that's a great way to put it. Well, we hope you enjoyed this deep dive into the world of geometry. Until next time, keep exploring and keep those brains working.